Let's start working with an example. It sounds wordy, it looks tricky, but it's not that bad. Let's read the question carefully. We have several screens where we are going to use the same question, so let's try to understand what's going on. So we have a block of mass 1.5 kilograms. So they give us the mass of the block. It is dragged over a rough horizontal surface by a force of 20 newtons acting at an angle theta above the horizontal. Okay? So this is the force F, and it is acting at an angle theta above the horizontal. They tell me that that force is 20 newtons, and it is acting at this angle. Then they tell me the block is displaced a distance d, 10 meters. Okay, and here they show me the displacement. Now they tell me if the horizontal component of the force is 10 newtons. Okay, now is the part that we need to worry about. What do they mean by the horizontal component of the force is 10 newtons? And listen here, they say the vertical component of the force is 17.3 newtons. What they are saying here is since the force is at an angle, it's going to act both along the horizontal and along the vertical. The portion that is along the horizontal is 10 newtons, and the portion that's along the vertical is 17.3 newtons. So in other words, instead of worrying about this force, we can worry about 10 Newton force this way and a 17.3 Newton force that way. Now, the combination of these two forces would have the same effect than that force F, the 20 newtons, at the angle theta above the horizontal. Actually, they never told me what the angle is, from what I see here. Okay? But that's what they are saying. Now, they say the friction force is 5 newtons. Okay? Here we have the friction. It is drawn. The question is, what is the net force on the block? And then what is the acceleration of the block? And then they ask us about the work done by the horizontal force, the horizontal component of the force F. Okay, now, the first part, they are not really asking for anything dealing with work. This is stuff that we have learned from the past. Okay, when they ask us about the net force, that's the unbalanced force. So now what do we have? We have forces along the vertical and forces along the horizontal. Now, the forces that are along the horizontal, they are the 10 Newton in the forward direction, so it's plus 10 newtons. And then we have the minus 5 newtons, the friction. So this is, let's call it Fx for the 10 newtons. And then we have Ff for the friction, the minus since it's pointing in the opposite direction. And that's it. Now for the vertical, I don't have to worry really about the vertical for the net force because we know that it is not moving up or down. So we know that along the vertical, my net force, vertical, is equal to 0. Now, however, for the horizontal, we have Fx and Ff. They are different. They are unbalanced. So my net force along the horizontal, which is my overall net force since the vertical is 0, then it's going to be just Fx plus Ff, which is plus 10 newtons minus 5 newtons, which is equal to plus 5 newtons. Okay, wonderful. Now that we know the net force, we can find the acceleration very easily. The acceleration, it is just net force over m. In this case, that's going to be plus 5 newtons over 1.5 kilograms. Okay, so 5 over 1.5 is 3.3 meters per second squared. So that's my acceleration. So I got my part A, the net force is 5 newtons, and then my part B, the acceleration. Now the last question is, what is the work done by the horizontal component of F? Now the work done is F times D. That's the definition. Now we need to check how much of F is parallel to D. F is along the horizontal, D is along the horizontal. So all of that F, that horizontal component of F, all that 10 newtons is parallel to D. Because it's fully parallel to D, that's all what we have to write. 10 newtons times the displacement, which is 10 meters, which gives me 100 newtons times meters, 100 joules. So the work due to F parallel in this case is 100 joules. That's my 3 questions. Okay, let's carry this forward. Now here, they are asking me to find the work done by the vertical component of the force. And then the work done by the normal force and the work done by the gravitational force. Okay, now the vertical component is this one. It is, we said before, 17.3 newtons. Remember the definition of work is F parallel to the displacement times D. I need to find how much of F is parallel to D. Now here, this is my F, what I drew in black here. This is my D. They're perpendicular to each other. So none of these 17.3 newtons is going to be parallel to D, which means my answer for part A, for this F perpendicular, is going to be 0. 17.3 newtons times 0, since there is no displacement parallel to it. Now, part B, think about it. It's not going to be much different, because what's the direction of my normal force? Straight perpendicular to the surface, which is straight perpendicular to D. So that means none of Fn is parallel to D. Then the work due to Fn is just equal to 0. Okay, that sounds fun. So you guessed it. The work due to Fg is also 0, because Fg is along the vertical, which is perpendicular to D. So there is no component of Fg that's parallel to the displacement. So the work due to Fg should be equal to 0. Okay. Now, let's take the other part. What is the work done by the friction force? Okay. The work done by the friction force, we are going to use the same definition. So, work, remember we said is F parallel times D. Now, look at what we have here. D is along the horizontal, pointing towards the right. The friction force is along the horizontal, but pointing towards the left. They are pointing in opposite directions. That opposite direction brings me a negative sign here. That's the friction force that's telling us it's opposing the displacement instead of contributing to the displacement. Instead of helping move forward, it is preventing it from moving. So that's where the minus sign comes. So it is going to be mine and our minus sign, and then the friction force is 5 newtons, and then times the displacement, 10 meters. And that's going to be minus 50 joules. So that's the work due to the friction force. Now, when they ask me about the work done by the net force, remember we found the net force before. We are going to use the same definition here. So the work due to F net is going to be F net times D. Remember, we said F net is going to be parallel to the horizontal in the same direction as D. So that's going to be just, if you recall, F net, we found it as 5 newtons. So it's going to be 5 newtons times 10 meters, or 50 joules. One thing to notice here, we found the work due to F parallel, we found it to be 100 joules. The work due to the friction, minus 50 joules. All the other works, the works due to all the other forces, we found them to be 0. So in other words, the work due to the net force is going to be the sum of all those other works, the works due to all the other forces. In this case, it was 100 joules plus minus 50 joules plus 0 plus 0 plus 0. That gives us 50 joules. And that's the same than what we just found by calculating it for the net force. Okay? This does it for this question. I hope you notice it's not that difficult.